Hello students, welcome to the course on hydrology EVE 301, and let's continue our discussion on flood estimation and control. So we have seen in last class, so there are various methods to estimate the peak discharge, and some of the methods to calculate the peak discharge are the rational formula, and there is some empirical equations, and we said the most adopted method is through frequency analysis. So frequency analysis means you should have a data set already with you. If you don't have data set with you, then this method is not appropriate. I mean, you cannot do anything with it because it needs some uh, values that is derived from the data set. So in our previous class we have studied about the various coefficients that you can derive from the data sets. So just to revise few things, the mean we have discussed is the average value, and there's a standard deviation, coefficient of skewness, and also there is a coefficient of kurtosis. So these are some parameters that is derived directly from the data set that is available. Having this data set and information and this coefficient in hand, then we can go through this frequency analysis through statistical method. Okay, and one method was proposed by Vintage Chow, and which says that the frequency, okay, the magnitude of a flood with return period of some time, okay, some return period time t, is equal to x bar. This x bar is the average value of all the data set that you have, plus the standard deviation times the frequency factor. Here you can derive x bar and the standard deviation from the value from the data set, but the frequency factor is a factor that depends upon the frequency distribution. So for that you should have to have a knowledge of what kind of distribution that data belongs to. So once you can figure it out that the particular data set belongs to some type of frequency distribution, or normally known as the probability distribution, then from there we derive this value frequency factor. Once we have frequency factor, we simply plug in that value here and we get the peak discharge. Okay, so that is the statistical method here. In our previous class we have also done the graphical method, which is known as position plotting. That was in first chapter. So if you have forgotten about it, please do revise that. So now, as I said, the frequency factor depends upon the distribution. So let's discuss on what are the distributions available. So one basic information that I can give you here is the the normally used distribution is the normal distribution, also known as the Gaussian distribution. It is the most generally used frequency distribution in statistics. So by definition it gives us a bell-shaped curve. It gives us a bell-shaped curve, something like this. Okay, and here we say that coefficient of skewness s is 0. The property of this normal distribution is coefficient of skewness is 0, and the equation that describes the frequency distribution is in this function. Okay, this is the function that describes this frequency distribution. On the same note, let me show you programmatically how you can develop such a curve. So you just have to take some random values of standard deviation and x bar, and you choose a random series. Then you can plot this. You can use a Python to do this yourself. So let me demonstrate this to you quickly. So here I have written a simple code and I'm just running this. So you can see, so this is the frequency distribution. You can see here, right? You can see this is the normal distribution. So I have simply plugged in the values, in just random values in the equation, and you can get this curve. So if your data set belongs to such a curve, then we call it frequency distribution, a normal distribution. Okay, so now the question is how we are going to calculate the frequency factor. To calculate frequency factor, what we need is we need the exceedance probability. We have learned that the exceedance probability is 1 by the time. This time is the return period. Okay, so based on this we plug in. First we calculate the omega. Omega is given by this equation, and kt, or the frequency factor, is a function of omega, and when you plug in the function of omega in this equation you will get the value of KT. Now here what we need to understand is this KT, as you have seen, is a function of exceedance probability, frequency distribution, and return period, right? Exceedance probability and return period, I mean, it's you can get this. If you have one value, you can get another, but still then I'm just mentioning it. So based on these three, you can calculate the frequency factor. Now, having this frequency factor, you have to simply plug in the frequency factor in the general hydrologic equation. So where is that equation? So this is the equation, okay, frequency factor method. So you just plug in the value here and then you can calculate the peak discharge. Okay, with this, and one more thing we need to understand is I am giving an analytical solution of KT. There is another approach whereby this KT is already tabulated. As you have already seen, the calculation, the formula is not that simple. So there are available some standards whereby you can simply plug KT value based on the the data set available. So that is what is done in your textbook. If I give this method, I would either give this equation to you so you don't have to memorize it, or I will give a standard table from where you can simply get the KT value. Okay, so having known this, let's go and solve a simple numerical. Okay, so here the question says calculate frequency factor for a normal distribution for an event with a return period of 50 years. So information that is given to us is the return period is 50. So exceedance probability becomes 1 by 50, right? Based on this, we plug in this value to the omega. Omega is it's ln of 1 by p square and everything raised to power half. So based on this, we can calculate omega, and you plug in the value of omega into the long equation here and you will get the value of the KT value, the frequency factor. On the same note, if our interest was to find the xt of return period, let's say 50, is equal to, now we need to x bar plus standard deviation times KT. So similarly, if I'm interested to find the peak discharge, I need to have some value of x bar and standard deviation. If x bar is, let's say x bar is 100 and standard deviation is 75, then you simply plug in this value in this equation and you will get a peak discharge for return period of 50 years. Okay, it's very straightforward. Okay, now that is what that was one distribution, one type of distribution, and which we call as the normal distribution. Now there is another distribution which is the log normal distribution. So we'll continue our discussion in the next class. So I'll keep it here for this time.